Good evening, good evening, good evening, good evening, everybody. I hope I'm clearly visible and audible to everyone. Good evening, good evening, good evening. Yes, so now I can see myself and I can see few comments as well. So, Hema, good evening. Yes, Hema 123, you have written 7:16. So I guess the time was 8 p.m. and we are just 30 seconds late to start. So I hope everybody is super charged up because beta, starting your JEE journey from the very beginning gives you an edge for the time. And if you talk of JEE 2027, that is next year, then beta, if you are in class 12th, then I would probably say you are already just if you do not just start right now, then you will be late. Because beta, if a day has 24 hours, then those 24 hours, in order for those 24 hours to be productive, you need right guidance, and that right guidance direct each and every student to more or less the right track. Now what is that right track for us? Sir, we have to be very much disciplined with our NCRT. At the same point of time, we do not have to mug that NCRT, because NCRT, if you ask me, as a book for starting, it is not at all a good book. But yes, if you know concept and you want to segregate that out of those many concepts, what are the important concepts, then you can have a revision of your content for maybe NEET, for JEE Mains, for JEE Advanced, or for bit set examination, for everybody, for every subject. Okay, so Akaf is here. Sir, is this for student who didn't heard the solution lecture of हाँ बेटा? So Akaf is our Laksh 2027 student. So I know him, and yes, Akaf beta, this is for those students who maybe have not heard the chapter, who has not joined Lakshya JEE in English yet, or maybe they are planning to do so. So if at all you're planning to do so and you have got a backlog somehow, for all our Laksh students, you obviously have your recordings that I have discussed in the morning also. I had a special class on Sunday this morning. So I've reported to all the students that you should definitely invest your time in the recordings. Why? Because even if you have joined late, then I guess I've completed solution chapter in my batch, in Lakshya JEE English batch, in around 12 lectures. Approximately each lecture was 1 hour 40 minutes, 1 hour to 45 minutes, because we need time to get into a concept which will make us sound enough so that we can easily attempt an advanced question. So we need a nurturing of the mind, and that definitely requires time. But because there may be many students in YouTube who have not joined Laksh batch, but they are planning to join it, but they have a dilemma in their mind that, sir, solution chapter is finished, electrochemistry is just going on. For chemistry I'm speaking, so how come they will be revising that? So this is a one shot just to make you revise the relevant concepts of solution. But again, for all my Laksh students who have already enrolled, but yes, I have seen few of the students have just joined a week before. So for them, I would rather definitely suggest that getting to the recordings per lecture is more efficient. But yes, if you are somehow not able to manage that time, then this one shot will definitely have a quick review of the solution chapter. So I hope everybody is good. I hope everybody is super charged up. So let us start the process. The chapter of solution and colligative properties. We'll be making it very crisp. We will be making it very precise. And with that, let us talk about solutions. So I guess this is a beginning of class 11th as well. So all the students who face, or my 11th is completely blown, then don't worry, because what was the foundational chapter for class 11th? Mole concept. What is the topic that I'm going to start solution chapter with? So 50% of solution chapter is nothing but class 11th. That is concentration terms. For concentration terms, you need to know mole concept. So we'll be discussing the concentration terms also, don't worry. But yes, even if I definitely know most of you will be watching this in a recorded format, because I do not see that much of student coming live, Still, I am discussing this with a frame of mind that many of you will be watching this in a recorded format. But beta, even if you are doing that, please take your pen and copy. You can obviously get these notes from PW JEE English WhatsApp channel. The moment I'll be finishing today's live, I'll be pushing these class notes over there. So it is free to be downloaded, and you can judge by yourself the level and the type and the class of question that we discuss in our batches. So you will be obviously amazed. You will be definitely appreciating it, because it will be definitely making you the best among all. Definitely, I mean, for that, even you have to put in your efforts equally, because ultimately, this JEE game, we are just mentors. It is you who have to perform and make this preparation journey worth it. So come on, let's start. Okay, so we have some new participants. So Sina Mong, okay, Cinnamon. So Cinnamon girl, good evening, beta. Then we have Naruto. Naruto is saying, sir, can you explain mole concept very detailedly? Yes, beta. I will be discussing first concentration terms only, so don't worry. Okay. Then you are asking who is taking physics in this batch, beta. Laksh English. The physics is taken by Gokul Krishna sir. He's BTech from IIT Chennai, so definitely worth it. If you just watch the classes, you will be amazed. Then Kishore is saying, sir, will you cover classes in YouTube separately? No, beta. These are just backup classes for all those students who wish to join. But yes, if you do not wish to join, then definitely, beta, we are all in there for you. But yes, we can't promise that we'll be coming with each chapter. But yes, whenever we will get a frame of time, and whenever we will get a request from you guys, so definitely accordingly, the YouTube is always open for you. Our description section, our comment section is always open for you, so you can definitely put in your comments, and definitely we'll be helping you for that for the other chapters as well. But yes, that may take time, and in the batches it may be quite segregated, and you definitely know at PW what we charge for batches. Nothing. So, okay, I hope I answered that. Kishore, then we have Naruto saying, Shreyas sir, okay, nahi beta, everybody is here. Everybody is here. Everybody is taking whatever is best for you. So don't worry. And I hope chalo, Kishore, chalo. Perfect, beta. So let's start now. What is a solution? So we definitely know solution is a mixture, but a mixture can be heterogeneous as well. It can be homogeneous as well. Heterogeneous mixture contain constitutes which are physically separable. I mean, you just can't separate them. If I mix sand and water, I can just put a channi, a separator, a sieve, and will pass the water from it. So water will be gone, and just with this physical technique, I'll be having the sand in my sieve. But sir, if I have a homogeneous solution, then the homogeneous solution which has all the components come in a single phase, single state of matter, that solution obviously JEE is also interested in, obviously NCERT is also interested in. So we will be focusing on specifically homogeneous solution. And what are these homogeneous solution? They have uniform composition throughout. Now, a solution is made of two or more components, but again, if our solution has two components, then technically it will be termed as a binary solution. Obviously, it may have three components, it may have more four components or quaternary. So you may have n number of components, like I take a glass of water. I will put a few drops of lemon into it. So solvent will be water because it is more. Solute will be those lemon droplets, but I may also add some salt. So that solid, once dissolved, will again turn into liquid state. So that salt dissolved in water is again a solute. I may add some black pepper. I may add some chaat masala. So I can add one or maybe n number of solutes. But for us, for JEE, for mains, for advanced, what solution we are focused in? We are focused in a binary solution. Now, sir, obviously, if you add n number of things, one component will be termed as solvent and all the other components will be termed as solute. So what is this definition of a solute? Solute can be defined as the component present in the solution other than solvent. Then, sir, what the hell is solvent? In order to define solvent, we have two definitions. The first definition says that component is termed as solvent which decides the state of the solution. If you mix two components, the solution overall mixture will also have some physical state, either solid, liquid, or gas. Yes, you may have Blows, Einstein, condensate, and plasma, but yes, for our JEE syllabus, we only focus on the three basic state of matter, which is solid, liquid, and gas. So whatever be the physical state of solution, who is deciding that physical state? The component which will be deciding is called solvent. A basic definition of solvent is also that that component is called as solvent which is in larger amount. If the physical state of both the components you have mixed are same, then what will be solvent? Then that component will be solvent which is in larger amount. I hope everybody is clear with this. Now, if you're clear, let us start with a basic question. This is sugar, a solute. No, 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 no. I'm not saying it is solute. I'm asking you that I have sugar and I have water, and they have made a sweetened water, a liquid solution. Why I'm saying liquid solution? Because obviously you can feel that, sir, the physical state of this liquid solution will also be liquid. Although we know sugar is an organic compound, it has very less solubility. But yes, if you keep on pressurizing, if you keep on stirring, then the solid will get soluble, because water is a universal solvent. But yes, you have to put in some efforts, some energy, and after putting that energy, that solution will become a meetha pani, a sweet water. And what is the state of that solution? Sir, liquid state. So who is deciding the state of this liquid solution? Sir, water. So this will be solvent. And obviously the sugar solid will be the solute, because after getting dissolved, you cannot see that sugar. So I hope everybody is clear with this basic definition. Now, identify the solvent and solute here. Sir, this is also in liquid state. Sir, this is also in liquid state. Sir, solution is also a liquid solution. Sir, physical state of both are same. Then you will be requiring the other definition, because the component B is larger in quantity. So the solution will be the solution will be composed of component B, liquid B, which will be termed as solvent, and component A, which will be termed as solute. So the other definition will help you, that which is solute and which is solvent. Chalo, moving forward. Chalo, let us solve this beta. Just take a few seconds and answer this by the time I read some comments. Ha. Yes. No. Naruto is saying solute is greater. Nahi beta, solvent is greater. I hope now you are confirmed with that. ये कौन सी बैच है बेटा? दिस इज नो बैच. वी आर जस्ट रिवाइजिंग the bridge for class 11 to class 12th. Class 11th physical chemistry basic is mole concept. The class 12th first and foremost chapter is solution and colligative properties. So we are bridging the gap by discussing mole concept relevant things also, and obviously we'll be completing solution and colligative properties. We'll try to complete solution and colligative properties also. So Titan, no, not Titan, IITN. I hope I answered you. Sir, are you going to solve PYQs? Yes, beta. How? Solving PYQ is the only holy grail to crack JEE. So obviously, with the concepts, I'll be discussing questions also, and those questions will definitely be PYQs. Yes, we will be having some good questions as well. But yes, let's see with the progress of the class. Because every class a teacher takes, it depends upon the students. So let us see the level of participation. But yes, even if I have no students, I can see most of you will be watching this in a recorded format, and or if not, if you're here, then definitely I will be sharing more. है ना? Chalo. So perfect. We are having answer. Sugar is solvent and water is solute. Yes. In a syrup, 60 gram sugar is present with 40 gram water. Now you can see, sir, weight of sugar is more, weight of water is less. But still, I will be saying water is in liquid state, sugar is obviously in solid state, and once you will form the sugar solution, it will be in liquid state. So who is deciding the phase, the physical state of the solution? Sir, water. Therefore, for water, I will be marking as solvent. And for sugar, I will be still, although the amount is less, that means it will be a concentrated solution. But still, I will be marking this as solute. So which definition supersedes for any component to be termed as solvent? Beta, it has to decide the state of the solution. I hope everybody is clear with that. Completed JEE Advanced 2026, came here. Okay, okay. So Harshit, welcome beta, and Vishnu, hello. Chalo beta. Moving forward, I hope everybody have done this. So basic questions now. Now. Sir, what are the types of solutions? Now, the type of solution depends upon what categorization you're doing. If you are talking of the amount of solute present in a solvent, on that front, then the solution can be saturated as in no more solute can be added. It can be unsaturated, that means at that particular temperature you can add more solute. Or it can be super saturated, like you have a syrup, sugar syrup has excess of sugar dissolved. Sir, obviously you can increase the temperature, dissolve more sugar, and then you can decrease the temperature, or maybe cool it down, and then at the coming back to the normal temperature, that solution becomes a super saturated, super concentrated, super saturated solution. But what we are interested in, what JEE is interested in, JEE is interested in, your NCRT is interested in types of solution on the basis of physical state. On the basis of physical state. Sir, on the basis of physical state, who decides the type of solution? Solvent. So we, in English, in terminology, we say solute in solvent. So if solvent is in gaseous state, then the type of solution will be termed as gaseous solution. If, I guess there's a printing error. If the solvent is in liquid state, then the type of solution will be termed as a liquid solution. And if the solvent is in solid state, then the solution is known as a solid solution. Obviously, solute can either be solid, liquid, or gas. Now these are some famous examples. That mixture of gas is an example of gas in gas solution. Mixture of gas as in the air, because air has so many components, but technically in air, what will be termed as solvent? Nitrogen, because percentage of nitrogen in air is maximum. So oxygen gas in nitrogen is termed as a gaseous solution with oxygen as solute and nitrogen as solvent. Liquid and gas solution, the famous example is chloroform in nitrogen. Solid and gas, the famous example, the camphor, the hoop, the camphor in present in air. What is air, sir? Basically nitrogen. Now, some few examples of liquid solutions. Gas in liquid as an oxygen dissolved in water, the only gas which is making the aquatic life possible. Liquid and liquid solution, sir, ethanol in water. So ethanol in water, I hope everybody can relate to that. I mean, most of you, at least you must have seen movies. So what is the third, another type of liquid solutions are solid in liquid, as in glucose or sugar dissolved in water. And similarly, you can have solid solution. The physical state of mixture can also be a solid. Obviously, then solvent, as in the component which is in larger amount, is also a solid. Like for example, gas and solid. So solution of hydrogen in palladium. Remember the hydrogenation that we do. Nickel, platinum, palladium, they provide a surface, and hydrogen and the unsaturated hydrocarbon gets adsorbed. So which is present in larger amount? So those metallic surfaces, those solid metals, who is getting adsorbed as in depositing on the surface. I'm not saying absorption, I'm saying adsorption. So that is the reason, because that is the process, that is the catalyzation that happens, because of which the hydrogenation of hydrocarbon take place, and from unsaturated hydrocarbon you produce your saturated hydrocarbons. Liquid and solid solution, sir, your melody these days, our PM is also flying here and there. You must have heard of that melody. So melody is itni chocolatey kyun hai? Because you have those liquid uh, liquid chocolate enclosed in a solid enclosure. So what metal is supposed to have supposed to be in liquid state at room temperature? Some mercury. So whenever mercury gets into a solid enclosure, the alloy, the composition, the solution is termed as a amalgam. So amalgam of mercury with sodium. So sodium enclosure will be having mercury, but mercury will be in lesser amount. So Hg in sodium is a example of liquid in solid solution, because ultimately the mixture will be a solid. Now solid is solid, the basic, your gold, because your gold ornaments, they are not pure, because pure gold is not workable. If you're wearing them, that means you must have made you must have paid some payment, extra payment for the making charges. You must have heard of it. Pure gold is not workable. You have to add some impurities. Now because gold is such a precious metal and these days it is more precious, so the categorization, the concentration term used is 24 carat, as in let's say for example you have 24 gram of gold. Then if it is 22 carat gold, then that means out of those 24 grams, 22 gram is gold and 2 grams are impurity. But those impurities are also solid, and that impurity makes the makes the gold workable. That's why you make designs out of it. Else if you have pure gold, then pure gold ring if you'll wear or chain you'll wear, it may be broken by just a fizz. So obviously you can't afford that such precious metal should be thrown away like this. So we do not wear jewelry of 24 karat gold, because you cannot draw out designs out of it. I hope everybody is clear with that. Sir, I'm getting very confused. Okay, in Raoult's law in colligative property, especially with many formulas type. Okay, sir, what should I do more to understand the concepts and formula? Beta, listen to me, listen to the class, invest the remaining, invest the upcoming, I guess 2 to 3 hours, and yes, then we'll be doing it. Anna, because obviously from solution and colligative properties, the most famous thing for JEE Mains, for probably JEE Advanced also, is solution in colligative properties, is those colligative properties calculations. And yes, concentration terms also. So that's why I'm starting with concentration terms, because I have this view in my mind that most of the students enter into class 12th have a feeling, sir, complete 11th is blown. Sir, what can I do? My complete 11th is blown. I cannot stand. I'm very, people are very much better than me. So don't have that feeling. I will be making that bridge from this class. But yes, a moderator, a educator can only guide you. It is you who have to study. So these are my notes. When they will become your notes, when you will study them by yourself. You listen to me 100 times. Still, while you will be giving your examination, you see me solving questions. Until unless you solve questions, you will never get that temperament. Chalo, moving forward. So I hope everybody is clear with the types of solution. Then now for going to the concentration terms mathematically. So for the case of simple calculations from now, solvent I will be marking as 1. Solute I will be marking as 2. So whenever I'll be writing 2 in the subscript, that means I'm talking of solute. Whenever I'm marking 1, I will be talking of solvent. And obviously if I have solution, so I will be marking solution as this. So this is for the case of mathematical ease. We are generalizing this. Only toughest concept in solution is mole concept. Beta, Naruto, don't worry. Naruto, don't worry. Concentration terms. Now, if you will be doing with me, you tell me. Just hang on for like next 15-20 minutes, and then you tell me. Okay, chalo. So coming to the characteristic of solution, so there are thousands and crores of types of solution. That's why if you have crores of people around, what you do, you characterize them by naming them. Like my name is Gaurav Singh Arora. If you have more people named Gaurav Singh Arora, then you will have categorization. What is your father's name? Yes, obviously you will not have same name and father's name, but if at all, then you will be having your blood group, that will be different. You will be having your DNA sample. So all those things are our categorization. Similarly, for categorizing so many types of solutions, we have defined some concentration terms. So point number one is you have to learn those definitions. So what are these definitions? The first concentration term is percentage composition. Now, what is percentage composition? Obviously, percentage as in you are marking out of 100. So you can mark this percentage as mass by mass percentage. So definition will be mass of solute. Remember, solute is for 2 upon mass of solution into 100. Like mass of solute upon total mass. What is total mass of such solution? Is nothing. Solution is a mixture of solute and solvent. So what is mass of solution? Sir, mass of solute plus mass of solvent into 100. What is volume by volume percentage? So volume of solute upon volume of solution. Sir, volume of solute upon volume of solution into 100. Now, sir, you are not putting any unit because obviously you are calculating percentages. So if you are putting weight in gram, you'll put weight of solution also in gram. If that is in kg, you'll also put this in kg. So obviously you'll keep the units same. But if mass by volume percentage is given, then you have to understand and learn this, that it is defined that if you are putting mass of solute in gram, then you are not free, you are compelled to put volume of solution in the denominator, but this volume will be in milliliters. So it is always gram per ml. Yes, it can also be kg per liter because sir, 1 kg has 1000 gram, 1 liter has 1000 ml. So obviously that 1000 will be getting cancelled. So it will be gram per ml or kg per liter. Obviously both are mathematically same. So you have to keep this thing in mind because many of the student miss this area and land with a -1 mark in their JEE Mains examination in 200. So it will give you percentage. Now, if I have a very dilute solution where even 20, 30, 40 parts is hazardous, if I have 1 million sample, that means if you have a factory around and the factory is not working religiously, it is tampering the environment around, then in such cases environmental ministry takes the water sample around the factory and check that whether the factory is doing religiously correct things or not. So for those components, for those solutions where even a small amount of solute is very, very dangerous for aquatic life, for our living mechanisms. So for those dilute solutions, we need some more concentration terms. So what do we have for them? Parts per million and parts per billion. Per million is 10 raised to power 6, per billion is 10 raised to power 9. Per million is 10 lakh rupees, so 10 lakh rupees is 10 raised to power 6. The tradition goes the same. It can be weight by weight, parts per million. It can be volume by volume, parts per million. It can be mass by volume, parts per million. But if it will be mass by volume, then again, mass will be in gram and volume will be in ml. If you multiply it with 10 raised to power 6, that means you are calculating this for a very, very dilute solution, and in that dilute solution out of 1 million part total, even if you have 40 parts or 45 parts of, let's say, fluorides, then it will be very hazardous. So that's why parts per million and billion is also used. I hope everybody is clear. Sir, in the question, there are like 0.1 mole, 0.1 molal. Molal, beta, Naruto, I will be coming on molality, beta. Just hold for a second. I'm just approaching that. Chalo. So, again, next concentration term is mole fraction. Shashi Tharoor use chi in order to signify mole fraction because obviously this is represented by x and this x is technically called chi, but we Gaurav Singh Arora called it x. If we will talk to some Shashi Tharoors outside, then obviously we'll also do this swag and we'll say chi, but right now let us be desi, so I'm saying it is x. Yes, obviously it is pronounced as chi technically, but I say this is x. So what is mole fraction, sir? As the name is suggesting you, mole fraction of 2 as in solute. Sir, it will be number of moles of solute upon total moles. What are total moles of solution, number of moles of solute plus solvent. Similarly, what will be mole fraction of solvent? So number of moles of solvent, I'm sorry, this is N1 upon total moles of solution, as in number of moles of solute plus number of moles of solvent. Obviously, you can see if you add mole fraction of solute and solvent, it will always be unity. But yes, it is valid for a binary solution. And again, I'm telling you, our JEE, our NEET, our advanced, our boards, everybody is interested in binary solution. So for binary solution, mole fraction of solute and mole fraction of solvent, if you add them, obviously you can see it will be getting cancelled and your answer will be 1. I hope everybody is clear with this. Now, let us attempt this basic question, beta. I am giving you 30 seconds for this, because let me sip some water, and by the time you guys can give me an answer for this question. Quick. Sir, I have a question. Please do ask Ankit. Please do ask Ankit. What does it mean? Beta, mole and molal. Mole, beta. Mole means number of moles, and molal is a concentration term called molality. Perfect, Vishnu. I hope people are answering. Perfect, beta. Chalo. Moving forward. I guess answer to the question is definitely which the students are answering. Yes, it is A, beta. Answer is definitely A, a very attemptable, a very doable question. Let me see the participants, your participation ratio. I guess the Pylons app is not working, but still I can see in the comment section people are answering. Perfect. So let us attempt this one, beta. The question is telling us mole fraction of NaCl in a solution containing 1 mole of NaCl. That means number of moles of solute is 1, and 100 gram of water, as in water is definitely solvent, so weight of water as in solvent is given out to be 1000 gram. We are supposed to calculate mole fraction of NaCl as in mole fraction of solute. So for that you need number of moles of solute upon number of moles of solute plus number of moles of solvent. So this already I know. So this is 1 upon 1 plus. But sir, I do not know mole fraction of solvent. Obviously a very basic and traditional thing, because few students were asking, so what is this mole? Mole can be calculated as weight of the substance upon molar mass of the substance. So what is the weight of the substance? The substance is water and its weight in gram is 1000 upon molar mass is mass of 1 mole of species. Mass of 1 mole is nothing but molecular mass, but you change that molecular mass in gram. That is the significance of taking this 1 mole species. So if you multiply 6.022 into 10 raised to power 23 with U, what is 1 U? Mass, atomic mass unit, which is mathematically nothing but mass of 1 hydrogen atom. So it gives you the weight in gram, because that multiplier is nothing but 1. So what is mass of 1 molecule of water, sir? 18U. So what will be mass of 2 molecules, sir? 18U into 2. 3 molecules, 18U into 3. 1 mole molecules, 18U into 1 mole. That will make it 18 gram. So it will be simply 18. And obviously number of moles present in 1 kg of water. I hope you should remember this also from class 11th. If not, then beta, this is a very beautiful I mean, it is a very useful, not beautiful, rather a very useful number. So 1 kg of water contain 55.55 moles. So I'll be just doing that 55.55, or else you can directly do this, because that will also help you mathematically, and then it is just mathematics and you will be getting A as your answer. I hope everybody is clear with this. Now, because students are very curious and they are asking, sir, molal, so let us move to the other concentration terms. The next concentration term is strength, rarely used but still very much important. What is strength? Sir, the weight of solute in gram upon volume of solution in liter, as in 1 liter of solution is containing what weight of solute? is defined as strength. So in short, this strength is nothing but W2 upon volume of solution in liter. That means unit of strength will be gram per liter. Now, if I change this gram in moles, then I will be getting the next concentration term, which is molarity. Again, beta, these definitions you should know. How you define molarity? First, it is written as capital M, and capital M, which is molarity, is nothing but number of moles of solute upon volume of solution in liters. Definition is you have to put volume in liter. So practically, the number of moles present in 1 liter of solution is defined as its molarity. Now, you can obviously simplify this, because in questions, generally volume is given in ml. So if I'm placing volume of solution in ml, then I am not allowed to do it because I have to put volume in liters. But you can have a mathematical justification for this. Sir, if you divide volume in ml by 1000, then it will turn in liter. So put that 1000 in the numerator. Now, what is number of moles of solute? The number of moles of solute is weight of solute, but this weight I have to put in gram, into molar mass of solute. Now, capital M independently I'm mentioning for molarity, and capital M again, but I'm writing 2, that means it is molar mass of solute. Now, these terminologies you should remember, because we have defined this. So at least these what are the definition of these symbol you should know. So 2 as in for solute, capital M as in molar mass, but in writing capital M independently, I'll be referring to it as molarity. I hope everybody is with me on this. So, sir, why you're specifying that this weight of solute should be in gram? Because molar mass is always in gram. So most of the time in your mains examination, you directly get question on this formula. And obviously, all the concentration terms which has volume factor in it, all the concentration terms which has volume factor in it are practically not good. Why? Sir, because volume changes with change in temperature. So if I have put a sticker of molarity on a bottle of, let's say, urea in the month of May in India, then obviously in winters, sir, volume of water, even the lakes around you, the volume of water is exponentially increased and decreased once you talk of May or once you talk of the month of December. So because we know, sir, volume is largely changed by change in temperature, therefore those concentration terms will also change. So you unnecessarily have to I have to remove the stickers and make them again, because the concentration is now changed, because volume changes with temperature. So definitely all those concentration terms which has volume factor in them are not very reliable, because they change with change in temperature. So better concentration terms should be who do not have this volume factor, who just have factor of mass. Although technically speaking, mass also gets changed with change in temperature, but if you compare them with change in volume, then obviously it is negligible. So all the concentration terms which has only masses factor in their definitions, they are considered as better concentration terms. That's why we have defined a better concentration term, which is small m, and it is nothing but molality. So molality, I beg your pardon, this will be small m, not capital M. So small m as in molality is nothing but number of moles of solute. I already have it over here, upon weight. Now whose weight? Not of solute, not of solution, of solvent. Please remember these definitions, they are very important. So weight of solute upon weight, number of moles of solute upon weight of solvent in kg. So again, if you put this weight of number of moles of solute, if you replace this, so it will be weight of solute upon molar mass of solute into, if I'm putting this weight of solvent in gram, then in order to convert it into kg, I'll divide by 1000. That 1000 will come in the numerator. The unit of molality will be moles per kg, or simply molal. One of the student was asking, sir, what is 0.1 molal? So 0.1 molal means beta molality is given, because this unit is generally termed as molal, and molarity is generally termed as unit of molarity is obviously moles per kg, but this is generally written as molar. Yes, it is nothing but moles per liter. So unit is moles per liter, or simply people write as molar. Similarly, for molality, unit is molal or moles per kg. Now, that I've already written that among molarity and molality, small m is better. Why? Because it is independent of temperature. Molarity obviously changes with temperature. How does molarity change? Because volume increase with temperature. Volume is inversely proportional to molarity. So molarity is also inversely proportional to temperature. I hope everybody got that. Now, just solve this quick question so that you can revise the basic formula. Acha, I can't, the pole, acha, over there. Okay, I guess that was, nahin, that was a MCQ, na? So this is, I guess, an integer type question. But yes, let's say I am asking you to answer this as dash into 10 raised to the power minus 2. So what will be your answer? This dash you have to give, and it will be an integer. Giving you 30 seconds for this. Quick. Shoot, beta. Try to give an answer. Quick. Try to give an answer. Quick. One. Okay. Ankit is saying one. You have to give answer in this form, beta. Dash into 10 is power minus 2. So dash will be your integer. So what will be that integer? Yes, it can be any integer. Come on, quick. Chalo. I hope time is done. And actually answer will be 10. Let me see. Answer is 10. I guess, guys, you are getting poll at your end, but still I can see people answering in the comment section. Yes, yes, Vishnu. Yes, Vishnu is saying 0.1. Let us check, beta. The question says, find out molarity. So I have to find the value of capital M of the solution in which 9 gram glucose, that means this is weight of solute, is dissolved in 500 ml of water. That means this is volume of solutions. A very simple one, but yes, you should not skip such questions because it will bridge you with confidence. So, sir, molarity is number of moles of solute. Number of moles of solute is weight of solute upon molar mass of solute. What is molar mass of glucose? C6H12O6. So this will be 180 gram into volume of solution in ml is 500. So to convert it into liter, I'll make 1000 in the numerator, and definitely once you'll solve this, you will be getting 0.1 as your answer. So it will be 10 into 10 raised to the power minus 2. So your answer will be 10. Not 0.1, beta, because I have changed the format. So please make sure, beta. Yes, answer is 0.1. Answer is 0.1. But please, beta, make sure, because JEE plays you with this. So please make sure you are working mathematically correctly, or else you may land to a bouncer. Chalo. Now, how to calculate resultant molarity. Now, for every student, I'm telling you one thing. I'll be discussing basic questions, but I will be giving you more questions. Sir, why you are not discussing, beta? Because obviously our target is complete the complete chapter, but all the students who are obedient enough, then for them, I have given homework questions also. Yes, I will not be putting HW in all the questions, like this one also. But yes, I am discussing the basics, and these homework questions are definitely for you, which you can definitely do with the concept that I have told you. Obviously, if you find problem after the live is done, you can go to the description section, just give the timestamp. I will be coming again with your backlog revision class, and definitely I'll be watching those comments, and I will be taking your doubts accordingly. But yes, you have to flood the comment section with your doubts, and whoever will be putting in those doubts, I will be seeing that more students are facing problem with a specific question of a specific concept. I will be again discussing it, but yes, I will be giving you homework to make you more disciplined, and you shall get this again. I'm telling you, you will be getting these notes once the live is done. Once the live is done, the notes will be shared in PWJ English WhatsApp channel. Chalo, let's move forward. Okay, good evening, sir. Now, who is this? This is Padmana. Okay, Padmana. Good evening, beta. How to remember formula, beta? Practice questions. Practice questions. The more and more you practice. Acha, Naruto. Do you remember any song? Naruto, do you remember any song? Beta, if the answer is yes, now you tell me, have you mugged that song? No. You have just gungunao that song. You would have just rhyme that song. No, 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 and it came to your head subconsciously. That is the way you should study also. Just read out as in speak aloud, so that your words can be heard by your ears. Just do it, don't try to mug it up, just read it. And while you're reading it, read it with that pace, so that you're understanding it also. Like, you're reading molarity is equal to, that means you're reading over here, m is equal to number of moles of solute. That means you're reading over here, I have moles of solute as an N2 in the numerator, upon volume of solution in liters in the denominator. That's it. Just do it for 21 days. I'm not saying do it for 21 days. Even if you will, you are, I mean, God forbidden, but yes, the study, the scientific study has given a scientific proof, statistical proof, that if you do one thing for 21 days, even if you are slowest, still it will become your habit. It will get into your subconscious. So I'm not saying you should revise it 21 times or 21 for 21 days. Even with 1 or 2 day beta, it'll get inside your head. But yes, you have to keep the iteration going. That is the discipline which is required, beta. Even if you're doing anything in your life, however, how much aptitude you're having, still if you're not disciplined enough, you are going to land with practically zero. So that is what JEE is asking you from this stage. You have to be disciplined. Anna, chalo, moving forward. I hope these homework questions I have discussed. I mean, yes, is there for you. So moving to the next topic. Okay, 0.9 out of molality. Which one does not change when temperature change? Why? Vishnu, I already answered that, beta. That is already there in the slide. So Vishnu, just hang on. Okay, let me. But beta, among molarity and molality, or among all the concentration terms which have volume factor in it, changes with change in temperature, because volume change with temperature. And all the concentration terms which has no volume factor and all mass factor, then they are practically independent with temperature change, and hence they are considered as better concentration terms. So molality, small m, is a better concentration term because it do not have any volume factor. So it is practically indifferent from change in temperature. Okay, Vishnu, chalo. So Ekaf is having peer-to-peer doubt solving. Hats off to you, Ekaf. Sir, how to make vapor pressure concept strong? I will be discussing vapor pressure, Rudra. है ना? Chalo. So let me be quick na. Don't keep me stuck in this. है ना? Chalo, let me be quick. Acha. Calculation of resultant molarity during dilution. Like for example, if I have HCl solution, let's say molarity of the solution is M1 and volume is V1. Let's say I have added water. How much water? Let's say I have added 500 ml of water. Now you have to tell me what is the molarity of final solution. Sir, nothing we have to do. What never changes? Sir, number of moles of solute is just here only. It is providing no solute. So number of moles of solute, initially, this was initially, and this is final. So number of moles initial is equal to number of moles of solute final. I'm just focusing on number of moles of solute. What is formula of number of moles of solute in terms of molarity? Sir, molarity initial into volume initial is equal to molarity final into final volume. Now what is my initial molarity? Sir, only this. I mean, initially I was just having this. I've added water. So solution is this. So what was initial molarity? Sir, M1. What is initial volume? V1. What is final molarity? Sir, this molarity we have to find. Let's say this is M. What is final volume? Sir, you have added 500 ml, but sir, this volume has to be in liter. So it will be V1 plus 500 upon 1000 because I have to put this in liter. That's it. You will be getting your value of molarity. I hope everybody is clear with this. Please answer. Okay. What to do, sir? What you asking? What to do, sir? Sir, I got 54 marks in advance, sir. So good, beta. If you want more marks, study more. Mohammed, chalo. Anything will you bring for IIT? Just like Bitsat? Yes, beta. We'll be definitely planning something. Alex, we'll be definitely planning something. So, but yes, put the request in the description, not in the comment, because everybody cannot see that comment beta. Our team definitely do not, I mean, it is very difficult to see the live comments. So whenever we are done with the lecture, just go to the comment section. Whatever request you put beta, we see those requests, I mean, very religiously, and we consider everything. So Mohammed beta, I mean, I was just trying to tell you, 24 mark, okay, you are dropper. Then beta, you have to plan things, Mohammed. You have to plan things. I understand it is a very crucial situation, beta, but you have to have a counseling. So let us have that counseling sometimes. Sometime, not this time because we have a job over here. But yes, definitely, beta, that requires a bit of discussion. That what you want in life, what should be the strategy for your level of aptitude. So that's a great process, beta. So talk to someone who you trust, who has who is capable and I mean who has exposure enough to give you a right guidance. Or else you can definitely, after the live, just go to the comment section. We'll definitely come back to you. But obviously beta, we have job to do over here. Now, as a beginner dropper, Laksh Press, Arjuna, JEE together I bought. Any hope for hitting? What? Why hope? Tushra, Tushar. Beta, why hope? That to 99.8. Why hope? Target 100 percentiler. And yes, hope is quite high. It all depends upon you. You have to be disciplined. What discipline? Whatever is taught regularly, na, don't don't do this, that. Whatever job you're having today, I've communicated the same in my Laksh batch today morning. What students have do is beta, once they start in the first week, in the second week, they work like anything. They work with super efficiency. And you know what they do? They finish everything on the very same day. They finish their DPPs also and everything. Once 2 week are gone, they cool down. Sir, 2 day lecture I have not done. I have just woke up because I want to go to some marriage or that or that. So that's why, sir, 2 day lecture is left now because 2 days lecture was a backlog. So everything become a backlog now. The only thing you have to do is be disciplined enough, finish everyday work on the same day, on Sundays or whatever day you are not having class, have a thorough revision of the complete week. I am telling you, you will be 100 percentiler. And if you do not do it, watch any one shots. It is not going to help you if you're targeting that high percentile beta. So be disciplined. Percentile is yours. Lose any day, you have to recover it. How you will recover it? Again, you have to put in double the efforts, no, because that day work is already there. You will be adding one more day work. So it is just basic mathematical statistical science beta. 8 hour job, do 8 hour job regularly. Studying 14 hours, 16 hours a day doesn't make a sense. Make it an average 6 to 8 hours. Be efficient in those 8 hours. Do every work regularly. If at all, some days, some more work has to be applied, then increase those 8 hours proportionally. But yes, it obviously not regularly, you have to do it. And every Sunday is a pause. Do not relax on those pauses. Revise whatever you have done for the week, and this is it. Hannah. Will there be 11th revision classes for chemistry? Yes, beta. Like this, we have planned today. We will be planning. I mean, if you are coming or for our batches, then definitely we have all the structure thing. First, we'll be doing 12th properly, and then whatever time we'll be left with, we'll be covering the 11th revisions also for Laksh. Okay. Okay, Mohammed, you are OBC. Beta, can I comment In video, sir. Yes, Mohammed, you can definitely do that, beta. Timing for Lakshya JEE. Naruto, it starts, the classes are from 6. You have two classes regularly, 6 to 7:45, 7:30, 1.5 hours, and then 7:45 to 9:15. I mean, yes, I generally take the 9 class and I extend it till 9:30, but yes, generally it is 1.5 hours. है ना? चलो, आई एम फ्रेश ड्रॉपर फॉर टॉपिक न्यू दैट्स ओके तुषार नो वरीज बेटा नो वरीज चलो chalo moving forward. So I hope everybody got this dilution thing now. Again a homework beta because you just have to do the same thing. Now resultant molarity during mixing, again you have to do the same thing, sir. Let's say this is also HCl. So let's say this is also HCl. This is molarity M1, volume V1. This is molarity M2, volume V2. Let's say I have added water also from outside. So let's say I am adding simple water also. Let's say V3. Then what is final molarity? So final volume will be V1 plus V2 plus V3 of water. This is water. Sir, from where moles are coming? Moles are coming from here and moles are coming from here. So final molarity will be total moles upon total volume. Total moles are coming from here. So number of moles over here, it will be, sir, M1 V1 because molarity is moles upon volume. So moles will be M1 V1 from the first compartment, I mean from this compartment, M2 V2 from the second compartment upon total volume, which is V1 plus V2 plus volume of water if added. If not added, do not add. Again, you will get such questions. So homework. I'm not doing this basic questions, beta. है ना? Now, see, a JEE mains question just on this basis. Sir, a student was saying, sir, you will do JEE mains. Beta, JEE mains is nothing. Do your basics correct. You will be getting JEE mains question. Sir, give us time to attempt. Beta, you have to complete till colligative properties. So, but yes, I have structured my, I will not be doing this HW everywhere. This is your religious duty. Once the live is done, go to PWJ English WhatsApp channel. Download these notes. Attempt them. Sir, how will I check what is the answer? See, in every you will be getting answer over here. So you can rectify. If you are conceptually correct, you can rectify what is your answer. Now, I am starting my job. I will not be doing this HW. Okay. Yes. For few questions, I'll be discussing. Chalo. So homework. I have given you. You do not need any DPP. The complete DPP, the complete module is here. But yes, your religious requirement is there. Chalo. So all these things are homework. Good questions. Acha. We will do a few. We will do a few questions. So JEE Advanced also, everything you can do. Now, huge packet of questions I have for you. See, I'll be discussing few, but yes, I have selected few questions which will be helping you. See, good number of questions. Now, see. Now, sir, will you not, sir? I will be discussing the best questions. Now, sir, why you have stopped? The reason. You know some concentration terms. Are generally those concentration terms directly asked? No. Advanced used to do this, but I guess after 2023, mains have also included those advanced questions. Now, because mains have included those advanced questions, so you need to understand the interrelationship between concentration terms. Now, what are the interrelation between concentration terms? The very first interrelation that you should definitely know is relationship between molarity, percentage, mass by mass, density of solution, and molar mass of solute. Now, here I have given you the formula, sir. We do not remember the formula, sir. It is very difficult for us to remember the formula. Then I am discussing the derivation also, because this derivation you can do directly in the question, and you have to do into divide. But yes, beta, that ways you will be required to invest a bit of more time. And if you want to save time also and do a question, then definitely you should learn these conclusions. But sir, definitely I'm giving you concept also, that why it is related like this. And if you do this for a question, the basic, if you apply in the question, then you will definitely do not have to learn. But sir, then the application, writing 3-4 lines will take time. Yes. That's why for an advanced level of question, it is good. Then, sir, we will ratify the formula. Nahi beta. Because then generally what advanced do it, they twinkle with the value. They will not give you this D is density of solution. Remember, this D is density of solution. So let me define this. M is molarity. We already know this. This percentage is weight by weight percentage. This D is density of solution. And whenever I'm saying density of solution, I also mean that this density has to be in gram per ml. So these are the specifications that you need to learn after learning the formula also. 10 is obviously 10. M2 is molar mass of solute. Okay. Sir, then shall we learn this? Obviously you should if you want to save time. But sir, I am very bad with learning formulas. Then let us derive it. You can do the derivation and you can attempt those questions. Okay. How to derive it, sir? Go by basic. What is molarity? Sir, for definition of molarity is number of moles of solute upon volume of solution in liters. If I'm placing this volume in ml, then I need 1000 in the numerator. Okay, sir. Now, number of moles of solute can be written as what? Sir, it can be written as weight of solute upon molar mass of solute. Remember, I'm not writing mm2. I'm writing m2. mm2 will let me, I have to write 2 times mm. I will not write. I've told you m2 solute, molar mass of solute. Okay. Now, sir, 1000 is already here. Okay, beta. Now, sir, but I need density of solution. No worries. This is volume of solution. Mass equals volume into density. So volume equals mass of solution. Mass of solution upon density of solution. That density will come in the numerator. But sir, you said this has to be in gram per ml. So beta, it is in gram per ml. So why? Because weight I'm putting in gram. Volume is already in ml. That means that this density is gram per ml. So why I will not have, let me beautify the formula. Let me have that in my mind that D is in gram per ml. Okay. But I know this is also in gram and this is also in gram. Now, one thing you know, what is percentage? Mass percentage, sir, weight of solute upon weight of solution into 100. So can you see weight of solute upon weight of solution into 100? This orange circle is what? Sir, this orange circle is the definition of percentage by mass. But sir, you will be having this extra 0. That means a 10 is still remaining. Then we have density of solution. In the denominator, I have molar mass of solute. And this is nothing but molarity. Proved. That means that this is common sense. Yes. So shall you do this common sense with numerical value also? Yes, you can. But sir, for doing this common sense, you have to write at least 3 lines. So 1, 2, 3. If you learn this, writing 3 lines will save time. At least 1.5 minutes maybe. Yes. But sir, I to cannot even learn the formula. Then better do basic. I've told you basic as well. Chalo, moving forward. Now, another important relationship, density of solution is equal to capital M as in molarity whole into 1 upon small m as in molality plus molar mass of solute, which is M2 upon 1000. But sir, I can't remember, so beta do basic. What is basic? Molarity is equal to number of moles of solute. I'm directly writing. Acha, okay, let me first write number of moles of solute. So number of moles of solute upon, so volume of solution. Okay, this volume is definitely I'm directly converting in ml because this is 1000. Okay, sir. Now, if I have this, then I can also relate molality. What is molality? The number of moles of solute into 1000. But in the denominator, you will be having weight of solvent in gram because this is weight of solvent in kg. I have 1000. Now, why you have done initially only, sir? Beta, because this is N2 by 1000, this is N2 by 1000. So in place of N2 by 1000, I can directly write M into W1. So I'm directly importing this. Therefore, I can say the value capital M, which is molarity, is nothing but instead of this N2 upon 1000, I'm doing what? I'm writing small m into W1. So small m into W1. Now every weight is in gram, every volume is in ml. I've already converted it, so I'll not write it. Now, sir, now I'm changing this. What? Volume of solution. This is molarity. This I've replaced, but now I'm replacing volume of solution. Why? Because I need density. So mass equals volume into density. So volume equals mass of solution upon density. So that density will go in the numerator. Perfect, sir. So, but this density I need in the left hand side because we learn the formula. So put this D in the left hand side. How, sir? Put everything over there. Sir, I can already see capital M, sir. See? So bring capital M here. So formula is getting constructed. Yes, beta. I reached this much. Now, whole into. But sir, I cannot see any plus. Beta, what is weight of solution? Sir, weight of solution is nothing but weight of solute plus weight of solvent. So instead of this weight of solution in this side, I've written this. What else, sir? This pink thing will be divided, sir. So divide this. Small m into W1. Small m into W1. Small m. Arey sir, W1 got cancelled. हाँ तो बेटा cut it. Arey sir, we can see 1 upon molality. So beta write it. Or I can say small d is equal to capital M. Sir, I can see 1 upon small. So write it, no? Plus. Go. Now, sir, I still have this. What? Sir, W2 upon M W1. Sir, I do not want this. I want something like M molecular mass of solute upon 1000. So, beta, just write one step for molality again. Molality can also be written as what is number of moles of solute? Sir, weight of solute upon molar mass of solute. Into I already have weight of solvent and I already have 1000. So, can you see that? Yes, sir. Where? So W2 upon M. So W2 upon M, then that will go in the denominator. So W1 is already there. So it will be, acha, it is 2, I'm sorry, because number of moles of solute is W2 upon M2, na, molar mass of solute. So this M2 upon 1000. So I hope you can see that M2 upon 1000 from this side of molarity. So using this, you can justify that and you can derive that. Sir, is derivation required? Again, I told you, if in the examination you are not able to recall the formula, then obviously do by basic. By basic as in put the values. I hope everybody is clear. Now, let us, okay, two more relationships. Then I'll be doing one question where I'll be solving without formula. Formula, you know, if you learn the formula, you can directly put the formula. But sorry, I don't want to. I am giving you, obviously, common sense also you can apply to have the. But yes, in your mains examination, it may save your time. It may. I'm not saying 100%. It may. है. But sir, if you are running 100-meter race, then daily you will practice only 100-meter. No, you run kilometers of distance. Then you try to run a 100-meter race. Similarly, if you are going to attempt 25 questions, you have to put in efforts, beta. Hana? So learning the formula also is good. But yes, you should know basic also. So we'll be solving questions also, how to do it basically. Chalo. है? No entrance preparation है? सर हिंदी सर बहुत अच्छे से हिंदी बोलते हैं मिस्टर वैभव बट बेटा जस्ट गो एंड सी द चैनल नेम बेटा सर इवन आई स्पीक good Punjabi because obviously I'm a Punjabi, but we are here at PW Punjabi English, JEE Punjabi no, PW JEE Hindi no, PW JEE English. So because we are here to communicate and connect with the students who are not comfortable in the language of Hindi or maybe another language, they are right because they are more comfortable in English. That's why this platform is created. Anna, so I hope I answered that, Vaibhav. Sir, that step is wrong. Shivani saying that step is wrong. Which step, beta? Which step, beta? M2 upon MW1. So W2 upon MW1 is M2 upon 1000. Is M2 upon 1000. Nothing is wrong, beta. Shivani? 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 सर बिटसेट वाला कमेंट देख लो प्लीज. क्या है बिटसेट वाला कमेंट? सर जी बिटसेट के क्लास ले लेते. सर जी व्हाट शुड आई डू फॉर बिटसेट? Aryan, okay, I am sorry, beta. I just missed that comment. Beta, we have done a session for Bitset. Just, beta, go to the chemistry live. Please first do that live, and whatever you doubts you have, just comment, beta. Whatever you want, na, coming and commenting in the live section will not help because our team checks the comment. What comments are after a video, a live is done in the description section. Below the description section, you have comment. put whatever you feel. We definitely watch it very. We have people, we have team just to see and reach out to your whatever you require, है ना? So beta, but commenting in the comment live will not help. So do that in the in any of the videos. We'll be definitely watching that, है ना? So bit said beta, and definitely I guess we have done physics, chemistry, biology, mathematics. In physics we have done those quant and English also I've seen. So we'll be coming up with whatever you need. But yes, you have to put that in the comment section. Huh? So when come Arjuna JEE 3.0? Nitesh, let us start Arjuna 1.0 in English first, beta. है ना? So okay. Sir, when come Arjuna JEE 3.0? Beta 3.0? You are talking of the English batch or what, Nitesh? Sorry for disturbance. नहीं, Shani, no worries, beta. No worries. We are all in there for you. So why sorry? If you are having doubt, I am very much happy to help you with the doubt. Chalo, beta, Nitesh bhaiya, do not, what is it called? Spam. Do not spam my live screen. Huh? We have very limited amount of students. So let us communicate, no. Nitesh, uh, I asked you, Nitesh, Arjuna JEE, as in you are talking of English batch or what? Sir, that's why, sir, any hope. If I start now, I am beginner dropper, sir. That's why any hope for 90. Nahi, beta ji, my dearest Tushar bhaiya, listen to me. Beta, if you are aiming high na, be disciplined. Start studying from now. Don't think work. Don't think about working. Work. From what? From now. From that is what you're doing. I've given you questions. Maybe you can, by the time I'm doing some communication with students, you can just browse back, pause, you'll be getting the questions. I've intentionally shown those questions. Many of you will be solving it. Many as in those who are actually serious enough. Anna, love from Bihar, sir. Love, I mean, reciprocating that love, Nitesh bhai. Sir, is this relation really important? Beta, as I already told you, I am from dash batch, sir. Okay, so Shivani, don't worry, beta. I cannot read dash. Okay, Shivani, I cannot read that dash. Okay, chalo. So Shivani, why you are? I read that, beta. Chalo. Moving forward. Now, so learning formula, I hope I answered, beta. It may help you sometimes, it may not, because some JEE generally they do not give, they give density of solvent. Then what we'll do by basic. So that's why we are doing the derivation also, because that will help you with basic understanding as well. है ना? Chalo. What's my age? I am 12 years old, beta. I am 12 years old. I am a minor. Chalo. Can I crack JEE? Yes, beta, you can. You have to trust yourself. So I am 12 years old. Nitesh, I am just a minor. Chalo. Moving forward. Now, sir, important relationships. So now, beta, let me be serious. Let me be serious. Let me be serious. Come on. There are students who will be watching us in the recorded format. So why we are, beta, if you're watching recording, make a 2x speed. We are entertaining ourselves over here. Beta, I had a long offline experience. And you know what? I used to have some classes in which for like, I mean, yes, I used to take around 1.5 hours, 2 hours class, because I love speaking to students. And sometimes even for 1 hour, we just chit chat like this. So that habit I still have. And whenever I see this lens, camera lens, I see you students. I see all those students standing in front of me. So a few of the people asked me, sir, we don't think you do not have any online experience. We feel you are very much comfortable. I said, once you see the camera, you see two red lines over there. I mean, just the red lines which make the eyebrows. So I can see those eyebrows. So I feel all the students are there with me. And whenever I get some response, so I'm always interested. Chalo, but I have to teach. Nitesh, keep quiet. Love back to Bihar. Shivani, you can crack beta. Study now. Now, molality. Sir, molality can be related to mole fraction. How? Sir, molality is equal to molality is equal to 1000 into mole fraction of solute upon x1 m1. So beta, very very important formula. Molality is equal to 1000 into x2 as in mole fraction of solute upon x1 m1. Sir, please help us derive it. Okay beta. Molality is number of moles of solute upon weight of solvent in kg. If I am putting that weight of solvent in gram, I will have to use 1000 in the numerator. Sir, why you have created a gap? Because you can, instead of weight of solvent, you can write, sir, number of moles is equal to weight upon molar mass. So weight will be equal to, sir, moles of solvent into molar mass of solvent. Still, sir, why you have created the gap? Beta, use your mathematical skills. If I add n1 plus n2 and divide it in the numerator, and again I divide n1 plus n2 in the denominator, is it making difference mathematically? No. Then beta, sir, what is n2 upon n1 plus n2? Sir, it is nothing but mole fraction of solute. What is n1 upon n1 plus n2? It is nothing but mole fraction of solvent. So can you see the formula? Yes, sir. 1000 into x2 upon x1 m1. Beta, this saves your time like anything because Advanced started it. Relation between molality and mole fractions. Advanced started it and Mains has copied that. I do not know how many number of times. So a student was asking, sir, is learning those formula helpful? You tell me. After attempting PYQs, you can do it with common sense, but you will have to write 2-3 more lines. Writing 2-3 more lines take time. And sir, we have hell less time. We need to invest in mathematics. So chemistry will give you marks also. And in order to achieve time also, yes, organic and inorganic mostly it will give you. But these sets are inorganic also, they give so many statements. You have to read those statements. So that's why making a good time manager, definitely it will help you. Moving forward. Sir, relationship between molarity and mole fractions, again, do that same common sense. Sir, molarity is equal to number of moles of solute upon volume of solution. Instead of volume of solution in liters, I'm writing ml, so I'm directly using 1000 in the numerator. Again, I've done it because I have to convert in mole fraction. But sir, I need density also. So volume of solution can be written as what? Sir, volume of solution, mass equals volume into density. So volume equals mass of solution upon density. So that density will also come in the numerator. Now, in place of volume of weight of solutions, a weight of solution is nothing but weight of solvent plus weight of solute. Sir, why write weight? Write in terms of moles. So in terms of moles, this will be, what is weight of solvent? Sir, it is moles of solvent into molar mass of solvent. What is weight of solute? Sir, it is moles of solute and molar mass of solute. That means that now this is my denominator. This is still my numerator. I will still use that mathematical reasoning. What, sir? Divide by n1 plus n2. Divide by n1 plus n2. Dividing the similar mathematical term won't make any mathematical change. Then what? Then, sir, you can use your I. Sir, this is nothing but x2. This is nothing but x1. This is nothing but x2. Beta, direct questions. I mean, not one. In your mains, in your advanced, you will get 18 to 20 questions based on these. 18 to 20 PYQs. If you talk of mains, maybe more. Chalo. Now, sir, what is the formula? Make us revise it. X2 into 1000 into density, X2 into 1000 into density upon X1 M1 plus X2 M2. M1 M2 are molar masses of solvent and solute respectively. Okay, चलो सर मैं AIR 100 लाऊं तो क्या गिफ्ट दोगे सर? बेटा बधाइयाँ. Because you know, if you will get AIR 1, AIR 100, you won't be requiring those gifts from outside beta. You will just be requiring blessings. Because if you are getting AIR 100, that means you are competent enough. You do not want, you will not be requiring any materialistic help beta because you are worth it. What you will be requiring is blessings. And that, with that, I am always there. है ना? So all the very best, Nitesh. But yes, beta, please have discipline also, because only discipline can take you over there. So all my best wishes to you, and definitely I know you'll do it. है ना? Chalo. Moving forward. Now, sir, you have said we will do some questions also. Okay. So let us attempt. Now, after knowing these, let us attempt. Let us attempt. I guess we were having more questions relating to that. Let us attempt this. No, no, not this one. This will be vapor pressure concerning. I had few questions. Okay, let us solve this only. Relationship with molality. Molality is where? Chalo, let us do this only. I guess we'll be having in the next slide. Okay, next slide, as in I have broken my slide into two halves. First half will be here. First half I'll be discussing. I mean, because if I make many slides in just one, this my my system gets hanged. So we'll be just taking 5 minutes break, and then I'll be coming back with those questions. So I'll be discussing one question that will help you to if sir I do not remember the formula, tell me how to do it basically. So I will solve few questions, है ना? But I guess we do not have those questions here. We have questions relating to interconversions of these concentration terms in the next slide. So I'll be giving you those questions, है ना? चलो. But learning that will also help you. But we'll do bit of questions also, है ना? Sir, is relation question are important? हाँ beta, that is what I told you. They are super flown. They are super flown in your JEE mains and advanced paper, and those derivations with those numericals, those formulas will definitely help you. है ना? Legend. चलो. Moving to the colligative side. Moving to the colligative side. Now, what are colligative properties? Colligative properties are those properties which depend only upon the amount of solute. Colligative properties are those properties which only depend upon the amount of solute present in a solution. They do not depend upon the nature of solute. Colligative properties are only valid for those solutions which are having non-volatile solid solute in a volatile liquid solvent. Point number one. Now, that means, sir, in your mains and board and JEE examination, what type of solution you are asked question from? We are asked question from liquid solutions. How many type of liquid solution we have? You can have solid in liquid, you can have liquid in liquid, and you can have a gaseous solute in liquid solvents. Ultimately, I want liquid solvent because for them we are supplied with questions. Okay. Now, that means colligative property are valid for solid and liquid solutions. Solute has to be solid. Sir, if solute is liquid, then liquid and liquid solution can also be there. What is the first colligative property? Sir, relative lowering of vapor pressure. What is this vapor pressure and why it is colligative? Because it will be depending only upon the amount of solute with respect to solution. Okay, sir. But sir, what is this vapor pressure? Let us first understand that vapor pressure. So what is this vapor pressure? Let's say I have this liquid. Now, if I have a molecule in the bulk, then sir, because this is liquid, that means the intermolecular attraction between the constituent species will be high. That's why it is in liquid state, or else it will be in gaseous state. Okay. So if we calculate the net forces of attraction on this liquid molecule in the bulk, sir, it will be having upside also, downside also, left also, right also, this also, this also, this also, this also. That means the net force, the net attraction force on this molecule in the bulk will be 0. Okay, sir. But if you consider the molecule which is at the top, at the liquid surface, sir, it is not having any molecule above it. And moreover, because it is not having any molecule above it which is attracting that particular molecule, therefore this molecule will be in a state of tension. Point number one, that is the surface tension that you should know. Okay. Now, at any temperature T, I am not talking of boiling beta. I am not talking of boiling. I am talking of the surface phenomena, that is evaporation, which can take place at any temperature. What happens is, what happens is molecules of liquid are present in bulk also, which are having zero force, but molecules which are present at the surface beta, they are not in equilibrium because the net upward force is not there. Moreover, sir, because they will have a net force, that means that force will be doing some work on them. Net force will be doing some work on them because F net is not zero. Sir, because some work will be done, that means some energy will be stored. And because there some energy is stored, that means they are of high energy. And anything that has high energy, sir, energy will always flow. So we are talking of the molecules that are present in the surface, very surface. Now, what happens that initially they start getting evaporated. Why? You have already told us, sir, they have energy. And because of that energy at any temperature T, because kinetic energy, the kinetic energy of even the gaseous molecule, kinetic energy is proportional to the absolute temperature. Whatever temperature you have at that particular temperature, they will have some kinetic energy, and with that kinetic energy they will try to move up. So that is rate of evaporation. So initially that rate of evaporation will be high. Why? Because if they are at surface, then they have nobody in the gaseous, in the space above their liquid. So initially rate of evaporation will be maximum, and sir, then they'll keep on evaporating, they will fill. But sir, every process is equilibrium. So the moment they are evaporating, they will be losing energy, and because they will be losing energy, they can go back. Sir, if they are going back after losing their energy, they will condensate and again come in liquid state. Yes, sir. So initially there are no molecules to get condensate. So initially rate of condensation will be zero and rate of evaporation will be maximum. And obviously we know no reaction, no physical processes also reaches completion. Where they reach equilibrium. Where they reach equilibrium. So once equilibrium is reached, rate of evaporation becomes equal to rate of condensation, and this can take place at any temperature. That means you will be having a saturated amount of vapors above a liquid, and at all temperature you will be having some vapors which will be exerting some pressure. If you observe that pressure using a barometer, that pressure of those vapors generated by the liquid is termed as vapor pressure. And my dear friends, these pressure are generated because of this physical equilibrium which you should know from class 11th. Let's say I have a liquid, a basic liquid, H2O liquid. Then H2O liquid will be coming in equilibrium and forming H2O gas. Now this is what, sir? This is a physical equilibrium. For equilibrium, we write the value of equilibrium constant because we are talking of gas, so we will be writing equilibrium constant in terms of partial pressure. Equilibrium constant in terms of partial pressure is, sir, partial pressure of product upon reactant. This is a gas, so partial pressure of hydrogen gas upon, sir, pure solid and pure liquid has practically, again, pure solid and pure liquid will also have some vapor pressure, but the vapors that they will form will be negligible. Because sir, if liquid is forming, then a solid can also form. How do you know it? Have you taken, I mean, just in the morning, just open your refrigerator, just take that ice cube out, and that ice cube will tell you, yes, although very less, but solid can also exert some vapor pressure. Yes, that vapor pressure you can see because of that temperature difference. That means the thing that you cannot see does not exist, or what? The solids and liquids will also, the solid will also have some vapor pressure, although that value will be negligible. But every component, the surface phenomena will be taking place, and the pressure exerted by your vapors at that particular temperature is called your vapor pressure. If you are talking of a liquid, then the pressure exerted by these liquid will be called vapor pressure of these liquids. Now, because this vapor pressure of water is actually equal to equilibrium constant K, sir, we know equilibrium constant only depends upon temperature. Equilibrium constant has no problem, has no business with the amount of liquid water taken. If I take 1 liter of water, if I take an ocean filled of water, Does equilibrium constant depend upon the amount? No, sir. K do not depend upon the concentration. K even do not depend upon this. Sir, K only depends upon the type of reaction, which is this, if H2 is getting evaporated, and it depends upon temperature. It do not depend. That's why if you have specific temperature, then at that temperature vapor pressure of water is also called aqueous tension. You must have heard aqueous tension is this, the humidity. What is humidity? The amount of water vapors present. Humidity is fixed in a certain area which has same temperature. No matter that land, that area is having any water bodies around or not. Yes, if it is having some water bodies, then maybe the thermal capacity of water is changing the temperature of the area. Then whatever area has been changed by those water body will have different humidity, not because other areas do not have water bodies, because the temperature of those areas are different. So my point is, aqueous tension as in vapor pressure of water is always a constant, because it is actually not depending upon the amount of liquid taken. It is equal to equilibrium constant K, and that equilibrium constant K only depends upon temperature. This is what you should know about vapor pressure, point number one. Now, obviously, if at this particular temperature, whatever is the saturated number of moles present, that saturated vapor pressure is called the vapor pressure. If you take out some molecules, then more water will come, because you have disturbed the equilibrium. If I take out these gaseous molecules, then more water will get evaporated. Why? Because ultimately the value at this particular temperature is equal to K. If you remove gas, then this pressure will fall, then it will become Q. So equilibrium got disturbed. So in order to oppose, more liquid will be vaporized. So, but still, the vapor pressure is just like a phenomena of a physical equilibrium, which only depends upon the value of K. So value of vapor pressure only changes on changing the temperature. It does not depend upon the amount of liquid taken. Point number one. Now, if you just know this, this is just basic question. Again, now conclusions. So this I have already told you, but let me summarize this for you, that vapor pressure of pure liquid is only temperature dependent. I've told you that. Irrespective of the amount of liquid and shape of container, vapor pressure is always a constant at particular temperature. If you change temperature, then only it will change. Liquid should be sufficient enough. Now this point, that the liquid should be sufficient enough. Like for example, let me make that video here only. For example, I have this vessel and I have just this much of liquid. Just this much of liquid at temperature T. Then if, like for example, this is a saturated pressure. This is a saturated vapor pressure. Let's say this pressure is 100, for example. I have just introduced liquid and all the liquid has vaporized, all the liquid has evaporated, but still pressure is 98 bar. So sir, still it is, if you add more liquid, it will again vaporize. Why? Because at this particular temperature T, what is the saturated value? Sir, 100, because it will be corresponding to the value of K. So if the vapor pressure does not depend upon the amount of liquid water, but the amount of liquid has to be at least that much, which can create that saturated level. If you change, if you have taken even less liquid than required for creating equilibrium, then it will not reach the value of K. So most of the students miss this. They say, oh, no, it do not depend. It do not depend upon the amount. That means if you take more, it will be independent. At least for having that much of pressure, provide that much of liquid, na? So it is saying that liquid should be sufficient enough. It should be sufficient that at least pressure is reaching till the value which is allowed by the value of K. If it is less, then yes, it will not be the saturated pressure, it will be less. Now, and vapor pressure depends upon temperature, that we already know, but the relation, the change of vapor pressure with temperatures is not linear. Many students make this mistake by saying, sir, PV is equal to nRT. So as you increase temperature, pressure will also increase. Beta, this is an equation for gas. We are talking of vapor pressure by a liquid. We are talking of vapor pressure by a liquid. So do not apply this formula, because relationship between vapor pressure and temperature is not linear, rather it is exponential. How do you know it? Because you know actually P is nothing but K. Actually vapor pressure is nothing but value of equilibrium constant K. So you should know how K changes with temperature. The relationship between temperature between equilibrium constant K and temperature is log of K2 as an equilibrium constant at temperature 2. Sir, why you have not written K2? Sir, because K is equal to P, pressure. What pressure? Sir, as K increases, remember this equilibrium form? Sir, as K equilibrium constant change, sir, pressure will change. So equilibrium constant at temperature 2 will corresponds to vapor pressure of the gas at temperature 2. So how this K is related with temperature, sir? Log of K2 by K1 is equal to delta H upon 2.303 R, 1 upon T1 minus 1 upon T2. You get this using Van 't Hoff equation. What is that basic Van 't Hoff equation? D by dt of ln K is equal to delta H upon RT square. So once you integrate this, take dt over there, integrate it T1, T2, you will get this formula. Replace ln K2 by K1 by P2 by P1. I hope everybody got it. The Prayas Gach, can it? Nahi beta, Tushar. Prayas JEE in English got stopped. Chalo. Okay. I hope everybody is clear till here. Moving to the. Now, sir, if I have more than one liquid, then you will get a liquid solution. Then what liquid solution will have vapor pressure? Yes, sir. That vapor pressure will be due to both the liquids. Yes, sir. Because if it is liquid in liquid solution, then both the liquids can create pressure. Yes, sir. Which liquid will create more pressure? Beta, then it will depend upon the intermolecular forces of attraction acting between the liquid. Sir, what are those intermolecular forces of attraction? Let us revise chemical bonding. The basic forces of attraction that you have: forces between ion, forces between ion dipole, hydrogen bonding, forces between dipole-dipole attraction, forces between dipole and induced dipole attraction, and last but not the least, non-polar molecules are also attracted by van der Waals forces of attraction, which is instantaneous dipole-dipole attraction. I hope everybody is correct. Okay, now, sir, can you give us a basic idea? Yes. For chemical, yes, that is a separate chemical bonding topic, but at least let me give you this much. What, sir? That the order of intermolecular forces. Sir, the strongest force of attraction is general. I'm not taking everybody, but yes, I'm giving you a general trend, which you should know through chemical bonding. The strongest force of attraction is hydrogen bonding. Sometimes even hydrogen bonding is regarded as a chemical bond. That means it is the strongest intermolecular force of attraction. Less than that is, sir, dipole-dipole attraction. Actually, hydrogen bonding is extreme case of dipole-dipole attraction. And least is van der Waals forces of attraction. What is this van der Waals forces of attraction? Actually, you should technically write London dispersion force, which is instantaneous dipole-dipole attraction. So this is London dispersion forces. I hope everybody is clear till here. I hope everybody is clear till here. Perfect. Moving forward now. Let us attempt this basic question from mains. Now this is, let me do this question because this is giving you a basic. I have three gases X, Y and Z. You have to tell me these statements based on the graph. So for this, because this is conceptually sound beta, therefore for this I am giving you 30 seconds, because this is a MCQ also, and I want to see the level of participation at least that we are having in the class. So yes, I can draw that also. Chalo. So then I'll be switching my slide. Yes, Aman Kumar, I definitely agree, beta. Obviously, I definitely agree. We all are just trying to match. Chalo, I hope everybody got it. So the question is telling us there are three statements based on this graph. X has higher intermolecular force of attraction than Y. X has lower intermolecular force of attraction as Y. Z has lower intermolecular force of attraction. So you have to compare forces of attraction. How can I compare it, sir? Beta, we have three gases. Okay, sir. Just keep a constant temperature. Now think that let us say at this temperature, X is reaching at a temperature of T1. Y is reaching the same pressure but at a higher temperature. Eh? Sir, same pressure, as you increase temperature, kinetic energy of gas will increase. Agreed. I know for vapor pressure of liquid, I know for vapor pressure of a liquid, beta, Mr. Bhattachar, beta, I'm repeating it only. That I'm not done it. I've just given question to attempt it. I'm repeating it. I have taken a constant pressure. Why? Because in order to reach that pressure, I am checking how much temperature you require. So X is requiring temperature T1. Y is requiring temperature T2. That means you have to heat Y to a more extent. That means the force of attraction of Y is larger. That's why it is so you have to supply more energy to break that intermolecular forces of attraction. And sir, Z is requiring even more temperature. That means the intermolecular forces of attraction of Z is definitely much higher, sir. So who will be having least intermolecular force of attraction? Sir, this will be having least and this will be having highest. I hope everybody is good with this. Now let's read the statement. X has higher intermolecular force. X has higher. Sir, definitely it is incorrect. Now what are you supposed to give? A graph of vapor pressure is given. Now the correct inferences. So X has higher intermolecular force. Sir, no, it is the least. X has lower intermolecular force of attraction compared to Y. Ha, sir, this is correct. This is correct. Z has lower intermolecular force of attraction. Z has lower. No, sir, Z is having highest. So this is also incorrect. So C is incorrect. A is incorrect. Only B is correct. Okay, but B is there in option 1. Now they are playing with data analysis. B is correct, but they are giving option B in option A. So many students make this mistake. So I hope you have not made this mistake. So answer is A. I guess the Pylons app is not working for you all, but no worries. So I hope Mr. Bhattachar, we are clear. Chalo, moving to the next one. Now, after this, beta, coming to after learning vapor pressure, now first let us first comment on the type of solutions. Sir, we have to read only liquid solutions. So vapor pressure of solutions first, because first colligative property is relative lowering, or in order to understand relative lowering, you anyway have to know about vapor pressure. So solution of non-volatile solute in a volatile solvent. Now I am talking of a solution which is having non-volatile solute as in a solid solute, in a volatile solvent as in a liquid solvent. Okay, sir, can you have a liquid solute in a liquid solvent? Yes, that also you can do. That also can be, because ultimately solvent will be creating some vapors. So liquid and liquid solutions and solid and liquid solutions can be dealt using your vapor pressure common sense. Now first thing is, if you have a solution which is containing non-volatile solute, what can you comment on the vapor pressure? Let us do it, sir. Let's say I have pure liquid. Let's say I have this H2O. Now I am adding, now this H2O is kept at temperature T. Again, I am not talking of boiling beta, because vapor pressure can be there at any temperature. So at temperature T, let's say the vapors it is forming is this. These are the vapors. And let's say this pressure of this pure solvent is P naught. This pure liquid pressure is P naught. Now, I have created a solution. How? Sir, you must have added in this pure solute some pure solvent, some solute. And what solute I'm supposed to add? A non-volatile solid. So let's say I have added some sand, because sir, sand, that dust particles, those solid dust particles, so they are non-volatile solute. If you add the sand, then at the same temperature T, can you comment, sir, definitely at temperature T, some of the liquid will be here. But can you comment that what will be the pressure applied by these liquids? Sir, you said vapor pressure only depends upon temperature. But beta, if the surface molecule had kinetic energy, the energy is given to them, is attributed to them by what? By the absolute temperature. Okay, sir. So let's say, for example, over here, these molecules have got, for example, these molecules have got 100 joule of energy and they have vaporized using that 100 joule of energy. Still, sir, because temperature is same, so energy is still the same. Energy is still the same. How much energy you are still providing them? Sir, 100 joule, this temperature T is providing them. That 100, out of that 100 joule, let's say 30 rupees, this solid has taken. Now this liquid has only got 70 rupees. It will create those pressure, but that pressure will be created by only utilizing this 70 rupees. And therefore whatever vapors you will be getting will be less, because sir, this solid has utilized energy, but it is not creating any pressure, it is not creating any vapors because it is non-volatile. That means if I add a non-volatile solid solute in a volatile solvent, the pressure of solution, which I am representing as PS, sir, this pressure will be definitely less than the pressure which was of the pure solvent at that particular temperature T. And this difference, which is P naught minus PS, is actually called lowering of vapor pressure. Now this vapor pressure is lowered how? So this vapor pressure is lowered because of addition of non-volatile solid solute in a volatile solvent. I hope everybody is clear. Now, if I divide, sir, what was the initial pressure? P naught. So if I divide with the initial value, as in, if I divide P naught minus PS with the initial volume, which is initial value, which is P naught, I will be getting relative lowering of vapor pressure. So this fraction is termed as relative lowering of vapor pressure. This fraction is termed as relative lowering of vapor pressure. I hope everybody is good. I hope everybody is good. Hello. Chalo. Perfect. Perfect, everybody. Now, sir, what is this Raoult's law? Again, in order to quantify this pressure, we have done some statistical experiments. Who was the scientist who has done that? Statistical. These are all statistical laws. So the scientist who has done the experimental analysis on these pressure is Raoult, and it is called Raoult's law. It is just a statistical analysis and rather common sense, because now with these scientists we have some common sense. So what is that common sense? This Raoult law just tell you that partial pressure of each component in a solution is proportional to its mole fraction in the liquid solution. Like for example, let me give a mathematical idea behind this Raoult's law. Like for example, I have liquid component. Now I'm just talking of liquid component. Let's say I have liquid component A. Then at temperature T, this liquid component is creating some vapor pressure. This pressure is P naught A, as in vapor pressure of this liquid component A. Okay, sir. Let's say I have another liquid, but this liquid is different, B. Depending upon the intermolecular forces of attraction between A and B at the same temperature T, vapor pressure of this will be P naught A. This guy will also create some pressure. Let's say this pressure is P naught B. Now let's say, for example, I'm assuming, let's say intermolecular forces of attraction of B is strong. Let's say B is H2O. So water has strong hydrogen bonding. So at temperature T, the vapors that water will be creating will be less. At temperature T, water vapors which A will be creating will be more. So if I'm assuming that if P naught A is more than P naught B, then I can say A is more volatile than what? So then B. if you mix them, sir, but you were talking of solid and liquid solution. I will come to that. First, let us talk of liquid and liquid solutions because I told you route law governs both. So if I add both of them, let's say I have A also and I have B also. Obviously, at the same temperature T, they will form some gas. At the same temperature T, they will form some gas. But the pressure over here will be PS, which is pressure of solution, because these were pure components and this is a solution. I hope everybody is with me here. Now, Raoult law tells us that partial pressure will be what? So pressure of solution will be what? So this pressure will be equal to partial pressure of A plus partial pressure of B, because it is composed of component A and B, and at temperature T they will form some vapor, some gas. Yes, some of the liquid will remain in liquid state also, like it is there in liquid state also, gaseous state also. So here also it will be in liquid state also and gaseous state also. In gaseous state, what is the total pressure? Pressure of solution. Pressure of solution will be, sir, Dalton's law we know. It is partial pressure of A plus partial pressure of B. Now, because this is partial pressure of A and partial pressure of B, so this we know through Dalton's law. Now, Raoult law is telling us that partial pressure of A is nothing but it is directly proportional to the mole fraction of A in the liquid, not in the vapor phase. The more I am in vapor phase, the more I have the contribution in liquid phase is the Raoult's law statistical application. As in, mole fraction of A in liquid state, let us say I'm representing as chi A if I'm Shashi Tharoor, X A if I'm GSA. Then, sir, what is the proportionality constant? We have again plotted graph for this, we as in Raoult for every liquid, and he has found that the proportionality constant was nothing but this value of P naught A when it was alone. So P naught A into XA. Now you can obviously prove it normally, conceptually. Sir, here, let's say number of moles of A is A in liquid phase. Number of moles of B is NB in liquid phase. Let's say number of moles of B in gaseous phase is NB, because moles of solvent B in gaseous phase will be different. We do not know at temperature T how many gaseous moles of B has been formed. So let us give it variable. It is NB dash. Number of moles of component A will be Na dash. So these are gaseous moles in of A and B, and these are moles of A and B in liquid phase. I'm not writing it, but I hope you are getting it. Writing as in, I'm not theoretically writing this is moles of gas and moles in gaseous phase, this is moles in liquid phase, but I hope you can understand with the diagram. Now, so that means what is this XA? Obviously, beta, XA will be mole fraction in liquid phase. So XA will be Na upon Na plus Nb, because in liquid phase, what is mole fraction? My moles upon total moles in liquid phase. Okay, sir. Now you tell me, if this liquid was having just A, that means mole fraction of A is what? 1. Because in here, there is no solution. So mole fraction of A is, this is completely mine. So mole fraction of A is 1 over here. So put XA1. Here, what is the pressure of A? The pressure of A will be P naught A. So this is common sense which Raoult has given us, but we know this is common sense because he has done those efforts and concluded it and made it a law which nobody has offended till date. I hope everybody is clear. So these are some statistical laws. Again, sir, similarly you can say partial pressure of B will be P naught B into XP. Now, if we use the conclusion made by Raoult's law and add that conclusion with Dalton's law, I hope we can have the pressure of solution. So what will be pressure of solution, beta? The pressure of solution is partial pressure of A plus B. This is Dalton's law. And partial pressure of A is nothing but P naught A into XA plus P naught B into XB. So this is a very famous formula which even JEE Advanced love asking. So the value of moles will be given and you can calculate the pressure of solution. I hope everybody is clear with me. Sir, I am so happy. Sir, before I have came to JEE Advanced live, sir, I am so happy. Okay, okay, beta. Chalo. Perfect. Chalo, moving forward. Now, I hope everybody is comfortable here. Okay, sir. Now, sir, I am talking of liquid and liquid solution. And this is the pressure of a liquid and liquid solution as per Raoult's and Dalton's law. One more important formula, beta. Can you relate mole fraction of A and B in vapor phase with mole fraction of A and B in gaseous phase with liquid phase? Yes, sir. How? Let us do that too. I'll be needing a slide. So let me duplicate this. Let me rub this. Okay, I'm sorry. Huh. Acha, beta, that slide will not be gone. I'm just using another slide because I need to do some rough work. Rough as in, let us, beta, certain things has to be written. Then only it gets to your head. So let me just utilize this because then I have to change my slide. I will. We'll take a 5 minutes break and then we'll meet again. है ना? चलो. Just 5 minutes break and then we'll be making it quick because I didn't want to make you wait for long because yes, most of you will be watching this in the recorded format. So we'll be just taking a 5 minute break because we have to change the slide. Acha, come on. Now, next thing is, so this much you told us. Now relate mole fraction of A and B in vapor phase with liquid phase. Okay. Then according to Dalton's law, beta, we also know one more thing. What? Partial pressure of A is what? Sir, what will be the pressure of A partially? Dalton's law tells us if PS is the total pressure, then how many fraction of A you have in vapor phase, they will decide the pressure exerted by A. So that means this is common sense. But that mole fraction we represent as Y because X is mole fraction we have represented for liquid state. That means number of moles of A and B in liquid state. But why I am representing for the fraction of molecules present in gaseous phase. So for gaseous phase, I am using the term Y. So mole fraction of A in gaseous phase into total pressure, which is PS. And we know, we also know that partial pressure of A, which will be the same value, has been derived by Raoult's also. And Raoult has said that this partial pressure of A is nothing but P naught A into XA. Raoult has related this with the mole fraction in liquid state. Dalton has related with the mole fraction in gaseous phase. So that means mole fraction of A in gaseous phase can be calculated as P naught A into XA upon pressure of solution. Similarly, you can calculate YB. YB will be equal to P naught B into XB upon pressure of solution. That is how you can calculate mole fractions in gaseous phase and in vapor phase. Sir, still you have not told us one thing. What thing? Now, if you have a solid in liquid, that means I have added A and B. Now this B which I am adding in A is not a liquid. If this B is a non-volatile solid, then sir P naught B will be 0. Then independently this sand will not be exerting any pressure. So sir, now this is simple mathematics for us. So therefore we can say we have already used Raoult's law. So again using it because again we have solvent. So vapor pressure definition will be applied. So P pressure of solution will be equal to P naught A into XA plus P naught B into XB. But now I have a solution which is definitely having a liquid. This is my liquid A. But now the B that I have dissolved, obviously it is not dissolved, it is a solid. So this solid, but at same temperature T, I told you pressure will be less. This pressure is PS. I know this pressure is less than P naught. Let us see it. Sir, for A, now I'll be writing just P naught because this is pure solvent. So pressure of solution will be P naught. A is nothing but P naught, which is pressure of solvent, into its mole fraction. I have number of moles of A, number of moles of A also I'll be having, number of moles of B also I'll be having of this solute. But sir, because P naught B is 0, so this will be 0. How can you write XA? Sir, you have already told us this is a binary solution. Mole fraction of A and B will be 1. So mole fraction is, it can be written as PS into P naught, and instead of XA, I'll be writing 1 minus XB. So that means it will be PS equals to P naught minus P naught into chi B. Or I can say P naught minus PS upon P naught will be equal to chi B or XB. Sir, XB is nothing but it is number of moles of B upon number of moles of A plus number of moles of B. Sir, B is my solute. That means this is the RLVP, which I have told you, relative lowering of vapor pressure. Now we know what it is. Now we conceptually know why vapor pressure get reduced when we add a non-volatile solid. And now we conceptually and mathematically and statistically know that this RLVP is equal to number of moles of solute with respect to solution. That means it is only depending upon the amount of solute with respect to solution, and hence it is a colligative property. And this colligative property is valid for solid and liquid solution. This colligative property only has mathematical and practical effect once the solution is dilute. You cannot have these calculations valid statistically also if the amount of solute is increased with respect to solvent. So amount of solute with respect to solvent must be very, very less. That's why we write this conceptually, that colligative property is only valid for dilute solutions, that too for solutions having solid solute which is non-volatile in a volatile liquid solvent. Can't I add a liquid component? Yes, you can do so. What application you'll have? Raoult's law, the formulas are already here. Yes, this is the first colligative property, and I guess beta acha, uh, there are three more after RLVP. There are three more colligative properties. Acha, so let us take a 10 minutes break beta, and then let us do it completely, है ना? So we will be meeting at, this is 10:01 na, not 10 minute. We'll meet at 10:10. 10:10 or 10, I'll be just starting at 10:10 or 10:15. Just do not go anywhere, because I obviously know we do not have much participants, but I hope most of you will be watching this in the recorded version. So because we have started, so let us finish at least those colligative properties. Yes, sir, you are not making us solve so many questions. Yes, beta. But I'm giving you those questions for homework now. So, and if you find problem, we will definitely meeting with the for the next class. I mean, for the backlog after the live. Hit the comment section with the doubts, है ना? Let us not waste time. We'll be meeting around 10:10 or 10:15. So just hang around and I'm coming back. I just have to save this and keep the another slide, है ना? Chalo. So 5 we'll be meeting in 10:10 or 10:15. Okay. Chalo. And we are back. And we are back. So, welcome again, everybody. Welcome. Umar is asking, sir. Umar is asking, sir, 3 4 topics from chemistry. Beta, periodic table, chemical bonding for bit set. Do that, please. K2CR27, K4 from NCRT. Then coordination compounds, that too. Uh, Beta, in fact, if you just, Umar, I'm answering you. If you just want to be confident with chemistry of bit set, make sure when you are attempting your bit set paper, you are watching options and then trying to give an answer. Point number one. Point number two, whatever live I have done now, just make sure you are doing all the questions. Yes, I have discussed, I have given homework also in that bit set live also. Download the notes. I hope you have got those lecture notes from WhatsApp channel PWJ English. Get those notes and revise those topics beta. They are more than probable questions, है ना? 11th. So Umar, already periodic table chemical bonding will make quite bit of 11th. Then do equilibrium beta. If you want to learn equilibrium specifically, then I have posted one shots of chemical and ionic equilibrium in the video section of the same channel. So you can watch that. Okay, so I'm from MP beta. Sir, I've seen your live. I've completed them. Then Umar, do practice then. Do more and more practice. Okay, perfect. Chalo beta. Let's start. Acha, somebody was asking, sir, when you'll complete colligative properties? Just now. Just now. Okay. Chalo beta. So coffee done. Let's start. Now, sir, we have read what is Raoult's law. Now, all the solutions. So we now know two types of solutions: liquid and liquid solution and solid and liquid solution. Now, talking of liquid and liquid solutions. So again, talking of liquid and liquid solutions. But sir, we were talking of solid and liquid solutions. First colligative property we have done, but now we are again coming to liquid and liquid solutions. Why? Ha. Chalo. Now, why we are doing again liquid and liquid solution? Because there is a term called ideal solution, very much loved by JEE. Now, what is this ideal solution? All the solution which follow Raoult law. What is Raoult law? The total pressure once you mix two components should be equal to what Raoult has calculated, which is P naught AXA plus P naught B XP. Sir, if two solutions give that value, then they are called ideal solutions. Now, what are these ideal solutions? That means once you have mixed them, they are